Hello, everybody. So today we're going to talk about quadratic regressions, which is how we're going to write the equations from if we have a data set for quadratics. We're going to be using our graphing calculator, so you're going to want to follow along with your graphing calculator. The steps we're going to use are outlined right here. So we're going to enter our data. We're going to hit the stat button and then hit edit for that, and we're going to keep going from there. So the first thing I want to tell you is we're going to need to do something to our calculator to make sure that it gives us what's called the R squared value. All right. The R squared value determines how the data fits a quadratic model, like how close the data fits. So we are going to use this when the second differences are close but not exact, okay? Or exact, either way, like it just has to be really close. And let me tell you what I mean by second differences. So if I have like X and Y as a data table, and like, let's say I had like, I don't know, like 5, 25, 7, 49, and 9, 81, all right? And I find the difference between these guys. Let's do 11 and 121 as well. Okay. So notice how the x values are evenly spaced. That's kind of important. So what I'm going to do is I'm going to find the difference of these guys. So 49 minus 25 is, 24. Is that right? Yeah, 24. 81 minus 49, not 40, so 32. And then 121 minus 81. What is that, like 40? Yeah. And you'll see that the difference between these guys is 8 every time. Because that's the same, right? And it's exactly the same. If we expanded this data table, it would be the same every time. And we went out 2 differences, right? First difference, second difference. That's the exponent of my equation. Okay, and that works if you expand it out even further. So if you had to go to the third difference to get the same number over and over again, it would be a cubic equation. All right. The closer our R squared value is, we're going to see what an R squared value is in a second, but the closer it is to 1 or -1, the better the fit. If an R squared value is very close to 0, it isn't a very good fit at all. If you don't have it, you're going to need to turn it on. So I'm going to switch over to my laptop so I can show you how to do all of this. Here we are in our graphing calculator. The first thing we need to do is make sure that something called our diagnostic is turned on. So we're going to hit second, and then we're going to go to 0. See how it says catalog? We're going into the catalog. This is a list of everything that the graphing calculator does. You can scroll down. I don't recommend it because see how we have like all the alpha keys that I talked to you about? Well, if I go ahead and hit the D one, it'll skip down to the letter D. That way we don't have to scroll through the whole thing. What we need to do is we need to scroll down until we get to diagnostic on, and then you just hit enter. And then it says diagnostic on, you hit enter again, and it says done. Cool. You've done it. You never have to do it again now. You only have to do that once. So now, what we need to do is we're going to need to enter some data, okay? To enter the data, we need to go to stat. We need to go into edit. Let's get rid of, I have a bunch of data in here. I'm going to get rid of it. I'm going to show you because you might have some data in here too. So let's get rid of it. You scroll right up to where it says L1 and you hit clear, enter. You hit clear, enter. You hit clear, and then enter. You hit clear, okay, every time. Okay. And now I'm going to need to enter my data. My L1 will be my X's, my L2 will be my Y's. I'm going to stop this recording so we can go get our data. Okay. S. Bones is a doctor in Deathley, Illinois, a suburb of Chicago. One day, John Garfunkel comes in with a high fever. Dr. Bones takes a blood sample and finds that it contains 1,300 flu viruses per cubic millimeter. I'm just going to highlight pieces of information that I see that might be useful. So takes a blood sample and finds it contains. All right, and it's increasing. John immediately gets a shot of penicillin. The virus count should continue to increase for a while and then level back off and go back down. After 5 minutes, it's up to 1875. After another 5 minutes, it's up to 2400. All right? So now what we're going to do is we're going to create, let's just create a data table from what I just highlighted, okay? I have, some X values and some Y values. When we started, there was 1300. 5 minutes later, it was 1875. Another 5 minutes later, it was 2400. We have our 3 data points. All right? Now we're going to enter this data into the calculator. So now what we're going to do is we're going to enter this data. So we got to this screen, remember, I'm going to show you again, by hitting the stat button. I hit edit, and I got to this screen. I'm going to type in 0, 5, and 10. Those are my X values. And my Y values are 1300, 1875, and 2400. Okay. Now, what I want to do is, if you're following along with the notes, we want to hit Stat, Calculate, and go to Quad Reg for a quadratic regression. Right? I hit Enter. Now I'm going to want to edit this for me. If it doesn't look like this for you, you're going to want to edit it as well. Okay? If it looks a little bit different, you're actually just okay to hit Enter. If you don't have L1 and L2 here, see how L1's right above the letter 1? We can type it in. Okay? All right, and see where it says Store Reg EQ? I'm going to want to store this because I don't want to have to type the equation in later. So I'm just telling it where to store it. I'm going to go to vars, stands for variables. I'm going to go to y variables. It's a function, y1, okay? And then I'm going to hit calculate. What it did by me typing in that y1 when I hit calculate is you'll see that well, we got the equation. It told me in standard form. So we have the equation. When I go to y equals now, it'll be in there already. It copied and pasted it into y equals. I don't want to quite do that yet, just because I want to go and write the equation. So my equation is ax squared plus bx plus c. That's the form, that's standard form. So my equation is negative x squared plus 120x plus 1300. And my r squared value is 1, meaning it's a perfect fit. The data is perfectly quadratic. Now I do have to tell you that any 3 points can always be perfectly quadratic. I just updated these 3 screens just so you can see them. These are just different parts of the calculator. You can't do this on your calculator, obviously. So you'll see in the y equals screen right here, the equation's already typed in, and then it's already graphing for me, and it's still in the table. All right. What we're going to do now is we have the equation, and you should write it down for part A. All right. Now let's work on part B. Okay. So we're going to go to the graph. Okay, that's no good. What I want to do is if I go to y1, see plot 1, I'm going to turn plot 1 on. What that's doing is it's turning on our scatter plot that we just made. Okay? And now if I go to zoom, you'll see that the 9th option is zoom stat. If I hit enter, you'll see that it kind of zooms in on the data that I graphed. Now, it's a little zoomed in for me. I want to see quadrant 1 with this kind of scale, so maybe I'll zoom out a little bit. Okay, that looks good to me. So now, here's what we're going to do, guys. I'm going to stop this recording a little bit, and I'm going to model how you should do these problems, okay? Okay, so our equation, if we recall, was y equals negative 1x squared. So I don't really need that negative 1. Negative x squared plus 120x plus 1300. Okay? And my graph looked something like this. We're just sketching. So this is 0, 1300. We know that from the C value. And we'll get what we need from here. We now, part C, so I did part A and B. Part C just says, Dr. Bones realizes that John must go to the hospital if the count reaches 4,500. Must he go? Explain. So what we need to do is we need to see, does this parabola cross 4,500 on the Y? I don't want to spoil it for you. So what I want you to do is try and see if you can figure it out. If you can figure it out, great. If you can't, if you're having trouble with that, I want you to come in with questions. I want us to start class with us for next class, okay? Have a good one, guys.